The moment arm is 90, is the application of force on a 90-degree angle. So here's my point of rotation. Here is where I'm applying my force. I'm applying my force in a 90-degree fashion. Just pretend this string is actually at the end here. So on a 90-degree way, okay, that would incorporate this entire lever, this entire arm within my that would incorporate this entire arm as my application of force. Meaning to say that it is a force multiplier, otherwise known as leverage. Okay. Now the concept of lever comes from Archimedes, which was an ancient Greek engineer. The famous saying that says, if you give me a lever and a fulcrum, and make sure that this lever is long enough, if I have a long enough lever and a fulcrum to put it on, then I can move the world. As we know, that when I have a short spanner, okay, I exert a lot more force needed in order to turn the knob, as opposed to when I have a long spanner, right? Or when I want to take out a nail with my hammer, if I hold the hammer close to the head, it's a lot harder to take the nail out, whereas if I were to hold the hammer, okay, towards, at the end of the hammer, at the end of the handle, it's a lot easier to turn, okay? So, we have the equation here that is M equals RF. So moment equals the distance multiplied by the force that I'm putting here. So I'm putting force in a 90-degree angle. That would incorporate this whole thing. I'm putting 10 units of force. I have about 15 inches of length on this lever. 15 multiplied by 10 is 150 units of force being put here. Okay. So now, where does it get a bit tricky? It gets a bit tricky, and this was confusing me for a while, is now what happens if I apply my force less than 90 degrees or more than 90 degrees, okay? So anything less than 90 degrees, application of force, it would incorporate a little bit of course, tension. See, I'm pulling on this, you see it's bending a bit. Anything more than 90 degrees, right, would cause this to, elongate, which would be tension. So tension coupled with my moment. So how do I calculate exactly how much moment I have? So we said we measured against the force application on a 90-degree angle. So just say I am applying my force this way, so it's less than 90 degrees. So then it would be incorporated within that compression. So I will take my application of force, which this line, so to speak, is the application of force because I'm pulling it in this particular direction. And then I would find where it meets up with my point of rotation on a 90-degree angle. So I'll take my 90-degree angle here, right? And I would follow it up along my point of rotation until I come to here, right? Here's my 90-degree angle over here, and that would make here, this distance from here would be, this distance here would be my, this distance over here would be my moment force. So in actuality, because I held it in that length, my lever actually became about 10 inches. So before, when I was using my whole lever, I had 15 inches multiplied by 10 units. Now I have about 10 units multiplied by 10 units. Okay? Which is 100 as opposed to 150 units of force. Now, just as we said with regards to with compression, the same is regards to tension. If I were to pull on it, this way, if I were to pull on it this way, right, it would still turn this way, unless I completely go over here. But if I were to pull on this way, it would turn, but it wouldn't turn as efficient because I have innate within this force that I'm applying, there is also tension. So how do I multiply? How do I find how much moment I have? Right? So there's a couple of ways of doing that. But the most easiest way is what I saw Nick do yesterday, and that is what you do is you put the application of force on the same angle but just in the opposite direction. Okay? And then I find my 90 degrees, right? I find my 90 degrees. I find my 90 degrees to that force application, right? So just say here, okay, so I find my 90 degrees, and that would be, let's say, that would be about there. 90 degrees would be this amount of moment force. Okay, so ultimately I have this amount of moment force, and this amount would be taken up by the tension. So again, before I had 15 or 20 inches of moment of leverage. Now I only have, again, about 10 inches of leverage multiplied by the force application, by the amount of force, the unit which I put on there was, let's say, 10. 10 multiplied by 10 is 100, which is a lot less than had I have put the force on a 90-degree angle, which that would have incorporated the entire length of my arm.